Hi everyone, welcome back to my channel and I hope you guys are doing extremely well. So today we are going to solve a very important graph problem that is called surrounded region. So this problem is frequently asked in an interview and it helps build a strong intuition for grid based DFS problem. So let's understand the problem first. So this is what problem statement is. So let me simplify it. What the problem is saying. The problem contain a grid of n cross m that will contain two character. One is x and another will be 0. Okay, that means the grid is of type character that will contain two character. One is x and another is 0. We need to convert all the O's into x that are surrounded by x. That means we need to convert all these O's into x because these are surrounded by x, and also we don't need to do anything with that O that are connected with the boundary. That means we don't need to do anything with this O because this is connected with the boundary. Okay, that's the simple problem statement. Okay, you got the problem? If you got the problem, comment understood. Okay, so what will be our approach for solving this particular problem? Like, think something like that will be extraordinary approach for solving this particular problem. The first approach, what will you get? Like, the first thing that comes up in your mind is we can find that surrounded region, and after that we'll convert all the O's into x. Yeah, that's cool. That's a great approach, but it's a time taking approach. Like, finding a surrounded region is a bit difficult thing for you. Instead of finding a surrounded region, what we can do, we can traverse the boundary. This is a reverse engineering process. What we can do, we will traverse the boundary, and after that, whenever we find any kind of O at the boundary, then we will mark it as safe. That's cool. That means when we traverse the boundary, like first we need to traverse first row, last row, first column, last column. So in the first row, you can see there isn't any kind of O. That means it's safe. Okay, that's cool. In the first column, there isn't any kind of O. That means it's safe. In the last column, yeah, it's safe because there isn't any kind of O. But in the last row, you can see there is an O. So what we need to do, we need to mark it as safe. Okay, so let me convert it into S. Okay, that's good. We mark it as safe. And after that, what we need to do, we will simply iterate over this grid and convert all the remaining O's into X. I hope you got. What we need to do, we need to traverse the boundary. Whenever we find any kind of O at the boundary, then what we need to do, we need to mark it as safe, and after that we will iterate over the grid and mark all the remaining O's into X. Okay, this will be our approach. So how will we traverse the boundary first? Okay, if you're asking like how will we, so we are using this formula. This is for the first column, this is for the last column. But how? Let's see. We need to iterate over the column. So for int I is equal to 0 till n minus 1, what we will do, we will do this. That means we will check if board of I 0 equal to O, Then what we will do, we will call DFS for I comma 0 comma board. Okay. Also, let me also what we need to check, we need to check for the last column. So if board of I comma m minus 1 equal to O, then also what we need to do, we need to call DFS for I till m minus 1 comma board. Okay, like if you are thinking like what is this, so let me explain you. If we put I is equal to 0 here, let me erase this thing and after that. Okay, if we put I is equal to 0 here, then what it means, this means this will be the this value. Is this 0? That means is this O? No, this is not O. Okay, that's good, we are safe this time, so we don't need to do anything. Now we will put I is equal to 1 comma 0. What is the value of 1 comma 0? That is x, so we don't need to do anything. That means it's safe. Now coming to the I is equal to 2. What is the value of board 2 comma 0? It's x, so we don't need to do anything. Coming to the I is equal to 3. What is the value of board 3 comma 0? It's x, so we don't need to do anything for the first column. First column is totally safe. Okay, can we put I is equal to 4? No. Why? Because n is equal to 4 and we need to iterate from 0 till n minus 1. That means we need to iterate from 0 till 3. Okay, that's good. Coming to the last column, what is the value of m? M is 4. So what will be the value of m minus 1? That will be 3. So let me put 3 here. Start I from the 0. What is the value of 0 comma 3? That is x. That means it's safe, we don't need to do anything. I is equal to 1. What is the value of 1 comma 3? It's x, we don't need to do anything, it's safe. What is the value of 2 comma 3? It's x, so we don't need to do anything, it is safe. What is the value of 3 comma 3? It is x, so we don't need to do anything. That means our first column and the last column is totally safe, we don't need to do anything with this. Okay, so that means we're done with this. We are totally scanned this column. Now we need to scan the row. So how we can scan this row? Simply we can scan the row like for int j is equal to 0 till m minus 1. We need to do if board of 0 comma j equal to O, then what we need to do, we need to call DFS for 0 comma j comma board. Okay, this is for the first row. What will be the formula for the last row? If board of n minus 1 j equal to capital O, then what we need to do, we need to call DFS for n minus 1 j board. Okay, that's good. So coming to board 0 comma j, what is the value of j? J starting from the 0. So what is the value of 0 comma 0? 0 comma 0 is x, so we don't need to do anything, it is safe. Coming to increase the value of j, what is the value of 0 comma 1? 0 comma 1 is also x, so we don't need to do anything. 0 comma 2, 0 comma 2 is also x, so we don't need to do anything with this. What is the value of 0 comma 3? 0 comma 3 is also x, so we don't need to do anything. Can we put the value of j 4? No, because j, we need to iterate from 0 till m minus 1. M is 4, so we what will be the value of m minus 1? That will be 3. That means we need to iterate from 0 to 3. Okay, that's cool. That means our first row is totally safe. We don't need to do anything with this. Okay. Coming to the last row. What is the value of n minus 1? N is 4, n minus 1 will be 3. Okay. G start from the 0. What is the value of 3 comma 0? 3 comma 0 is x. That's cool. That's safe. We don't need to do anything with this. What is the value of 3 comma 1? 3 comma 1 is O. Okay, 3 comma 1 is O. So we need to call DFS for 3 comma 1 comma board. Okay. And after that you can see all similarly we can put 2x, that's safe. We can put 3x, that's safe. So that's the same approach. Now we are moving towards this function DFS. So before calling DFS, we need to check something. What is the value of I? I is 3, j is 1. That's cool. And we need to check something, like we have some boundary condition here. If I is less than 0 or I is greater than equal to n or j is less than 0 or j is greater than equal to m or board of I and j is not equal to capital O, then what we need to do? We need to simply return from here. That means this is the boundary condition. Yeah, here I is greater than 0, I is less than equal to 3. That's cool. J is greater than 0, j is greater than equal to m. That's cool. Okay. Board of I and j, board of 3 and 1 is O. Yes, it's so. So what we need to do? We need to, that means it is satisfying this condition. I should be greater than 0. I should be less than equal to n. Less than n. J should be greater than 0. And j should be less than m. And board of I and j should be 0. O. Okay, that's cool. That means it means it satisfies the condition. So we don't need to do anything. That means we are in the boundary condition. After that, after checking all these conditions, what we need to do? If it fulfill this condition, then we simply need to convert board of three, that means board of I and j, that means 3 and 1 equal to capital S. That means we mark it as safe. So let me do one thing, erase all this thing. Now after that what I will do, I will mark wait. Okay, I will mark this O as capital S. That means it's safe now, so we don't need to do anything with this. And after that, what will we need to do? We need to check all the four direction. That means we need to check for upward, downward, left and right. Is there any kind of O? No, there isn't any kind of O in all the four direction. How can we check the how can we check in all the four direction? That means if we want to check upward, then what we need to do? We need to subtract 1 from the row. We need to check 2 comma 1. Okay, if we want to check downward, then what we need to do? We need to add 1 in the row. That means 4 comma 1, but 4 comma 1 is invalid because we don't have any kind of fourth row. Okay, if you want to check in the left, then what we need to do? We need to subtract from the column. That means here column is 1, so we need to check for 3 comma 0. That means we subtract j minus 1. 1 minus 1 will be 0. And if we want to check for the right, then we need to add 1 in the column. That's how we can check in all the four direction. Yeah, okay, that's cool. We have checked all the four direction. There isn't any kind of point in the direction of this particular node. That's cool. Now after marking this thing, what we need to do? We need to iterate over this grid. But how we can iterate? So what we need to do for iterating? We'll start from for int I is equal to 0 till n minus 1, for int j is equal to 0 till m minus 1. What we will check? If board of I and j equal to capital O, then what we need to do? We will simply convert it into capital X. That's whole thing. We are done with the problem. And also what we need to check? We need to, let me mark it as X, capital X. This will be capital X. This also will be capital X. Also we need to check, is there any kind of S? That means is there any kind of safe node? So we need to convert it into its original form. Okay, we need to check. So let me check. Else if board of I j equal to capital S, then what we need to do? We need to convert board of I j equal to capital O. Okay, that's done. That means okay, that's done. This is the dry run of this particular problem. So let me write the code once, and after that we will move forward. So as you can see, we have some board grid. Okay, so this is the code for this particular problem. Let me check whether it's working fine or not. Okay, this is the DFS function. So let me once check the yt.cpp.exe. Okay, so let's 4 comma 4. Okay, x X X X. Okay, X O O X X X O X X O X X. Okay, that's the correct output, as similar as our output. Yeah, let me check. Yeah, that's the same output you can see. So overall this problem is based on the reverse thinking, where instead of capturing the region directly, we first protect the boundary that is connected region using DFS. So then we flip the remaining O's into X, ensuring that only surrounded regions are captured. Okay. So overall, this is a classic grid DFS problem and very important for interview. As you can see, this is the code, and I have also share a dry run with you. So alright guys, that's it for this problem. If you found this helpful, make sure to like the video and subscribe to the channel. More such DSA content coming soon, so stay tuned and keep practicing. Till then, that keep coding, keep cheering. Bye bye.